John Bohannon, Senior Director of Data Science and also Head of Research at Primer.ai. Welcome to the Data Exchange Podcast.
Lovely to be here.
All right. So NLP, I'm an avid user of NLP. I don't train large language models from scratch myself, but I am a beneficiary of all of that goodness. So you guys put out a blog post on your kind of R&D areas of focus. So let's start there.
Yeah.
But this will be a broader conversation about practical NLP and translating research into products. So actually, the first item is really intriguing. Zero-shot entity recognition, which I'll let you explain, but I'm a skeptic.
Yeah.
But
Yeah.
I'll let you explain what you mean by that.
Yeah. This is one of our biggest research bets right now. So first, entity recognition is I give you a piece of text and I say, go highlight with different colored marker pens the following classes. I want people, I want locations, and I want organizations. So that's a very famous example of entity recognition called named entity recognition. So then, you got your blue marker for your people and you go burp, 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 and so forth. So usually you need a lot of training data for that. It's a particularly data hungry task. At least my intuition for why it's
which is why a lot of probably like circa 6-7 years ago, you'll try one of these NER libraries. Mm-hmm. They never work on your data. It only works on the test data.
It's notoriously bad at generalizing out of domain. It's notoriously bad at efficiency. If you only have 100 or 200 examples of the entities that you care about in your data, you'll be lucky if you get F1 scores of 60%, and that's not nearly good enough for production. So we had this idea: what if we could make a zero-shot entity recognition model that you could just say in English what you want, and then you give it text, and it does a pretty good job right off the bat, even if it's never seen a single example. So zero shots, got 0 shots at learning this.
So what is so it's like a natural language prompt, give me all the company names.
You got it.
Right.
And so we have 2 uses for this. First is just the pure 0-shot use case. Let's say that you're a data scientist and you just want to rapidly prototype. You've got a new customer, or you've got some interesting new problem, or just some crazy idea. Wouldn't it be great to immediately start to process documents to find true positives for the thing you care about? You're not even, you just dream up something that you're interested in, and it does a pretty good job already. And that's useful because you're at an exploratory stage, or you're doing a demo for a customer or whatever. But a second use case, and this is the one that we are really motivated by immediately, is you can take that 0-shot model as the base model to further fine tune for the problem you care about. So let's say that you have a customer who's interested in finding weapons in text. They have 1 million documents, and what they really want to know is, find me all of the instances in this text of people talking about weapons. Okay, well, you could train a weapons entity recognition model, and you're going to have to go get a representative sample that's well balanced, that's challenging and instructive for the model. It's a lot of work. And if you start with a vanilla language model, you're going to need thousands of examples that meet those criteria. And it's going to take you weeks. Just sign yourself up. It's weeks of work. But if you have a really good base model that's already pretty good at the task of finding entities in general, you could just give it the prompt, I'm looking for weapons, and it just does quite well out the box, and then you basically correct its mistakes.
So a couple of questions. So you alluded to the fact that just using one of these language models or embeddings, because I find actually there was this quantum leap from taking one of these NER models and now using, instead of just old style NER models, using some of these newer embeddings like sentence embeddings. They work amazingly well out of the box, but as you say, not good enough for production, but a lot better than what it was 6-7 years ago, right?
Sure. And they're getting even better. I mean, now we have multilingual embeddings.
Right,
really
right.
cool.
But what about, so I guess I'm hung up, John, on the part of the description of zero shot.
Okay.
So
let's dig into that.
So let me
people often confuse what zero shot means.
Here's my skepticism, right? So
Yeah.
I take one of these models it might be good in healthcare.
Mhm.
I point it to some really narrow area in cancer research.
Yeah.
There's no way it's going to work
100% agree.
Okay.
100% agree. Yeah, I think it'll work for like a large portion of cases, and then you've got the long tail of just like really bespoke stuff.
Or even in this particular medical system, right? So we might be in the both same areas of cancer research, but this part of the world uses different terms, right?
Yeah.
So, I don't know. Yeah.
So the data we're using to bootstrap this thing is Wikipedia and Wikidata, specifically English for now. We're going to move to multilingual eventually, but just trying to get it to work in English. So genes are something that it can recognize. Proteins are something it can recognize, like lots of biomedical terms.
So as long as it's in this data sources, it's pretty good.
So like it won't be useless for most use cases.
But you would have to like point it. So for example, if I'm interested in startups, you may have to point it to Crunchbase. If I'm interested in some area in healthcare, you'll have to point it to some, or train it in some, medical repository. Right?
You're always going to have to further fine tune. You're going to have data from the actual distribution you care about, and further.
How much data do I need to find?
So we've measured it. In the case of the kinds of entity recognition models we have to train at Primer, which are pretty diverse. So we really tried to challenge ourselves with like a truly diverse sample. If you just start with a vanilla-based language model and fine-tune on data that you care about, you typically need 2,000 balanced examples per class to get to true production ready. That's like the minimum, absolute minimum. So if you have a 5-class model, that's 5 times, that, unless you're lucky and they all co-occur and you can get more lemonade out of those lemons. But with a zero-shot model as the base, we have seen 4x data efficiency speedup. So you need 1/4 of that data to achieve the same performance.
And so then I assume Primer has it set up so that the domain experts who are non-coders can do some of this kind of enhanced data labeling.
So we have an in-house data labeling tool, and we have a partner startup called Odetta that we've worked with for years now. We're totally like buddies now, like we're in each other's Slack and Jira integrated. It's like a really great partnership, and they do human labeling. It's pretty rare that there's something so bespoke, so subject matter expertise required that they can't do it. When that's the case, we just source those experts separately. And sometimes, this is the worst case, the subject matter expert can't even see the data because it's proprietary or classified, in which case you need to take the customer and train them up and work with them, or you actually need to have a forward deployed engineer go into their org. And we've done all of the above. We've done all versions of this.
So for listeners who don't actually label data, quantify 2,000 examples, how many hours is that?
It really depends on the task, but in general, like if the text is short, so if the task is read this entire document and find the answer to some question, it could take you as much as half an hour per doc. But if it's like, here's a tweet, now underline these kinds of entities, then you're doing it in like 15 seconds max.
Right.
And so that's a huge range, but in general, 2,000 examples to do it right is gonna take 2 to 3 weeks.
And
you're gonna have to have multiple labelers. You have to train.
Yeah. Best practice means you need multiple labelers, right?
Yeah. And that means that they need to be managed. You need to have either consensus mechanisms or a neat trick we use called dataset cartography. Happy to get into that if you're curious. And yeah, in the end, it really does take 2 to 3 weeks to get a good data set.
So then I have this labeled examples for my domain. I start out with your kind of off-the-shelf NER, which is pretty good.
Yep.
So then after that, I just feed this labeled example. So everything is no code at this point for the user.
Right. You're just labeling.
Right.
Then the data scientist has to go and train a model.
Oh, I see.
The dream of AutoML is not yet a reality in NLP.
I see.
I don't know if everyone's on board with that, but that's my view.
Yeah. Some people are trying to do that at this point.
Oh yeah, we've been trying. It's a really hard nut to crack.
So by the way, so NLP is generally a pipeline, right? So in this particular example, we're talking about entity recognition.
Yeah.
Maybe your starting point is these embeddings, and then you have a classifier at some point, right?
Well, actually, the pipeline starts even earlier. Like you have to hook up the data.
Yeah.
Usually, customers have streams, not lakes.
Right.
It's not a one-off thing. It's like we have a never-ending stream of such docs. So there's so much software engineering. The ML part is really just a little box.
Right. But then, so what you're really retraining is this classifier for the entities.
Yeah.
And so, are those still deep learning at this point?
Oh yeah. The model that powers the entity recognition is a deep learning model.
Yeah.
Right? Like Roberta or
So
whatever you're using.
Yep.
There's a language model. Otherwise, it wouldn't work.
Exactly. All right. So then the next item is inference triage, which basically seems like just a deployment pattern for deploying a model, right? Like a
exactly
cascade.
that, but with a little bit of data science know-how baked in.
Okay. Yeah.
It's
you guys should use RayServe, because RayServe can support complex deployment patterns.
Oh yeah, well,
full disclosure, I'm an advisor to Anyschem.
You know what? Like the more the merrier. That we need more in this ecosystem because so the idea behind inference triage is here's the whole story. Like we looked at our AWS bill and just gasped. Like it's first of all, by the way, if anyone out there knows how to make tools to keep track of GPU costs, like in a big complicated team, if you've got a team like Primer with,
I think there are tools like that.
Yes, there are. Yes, there are. Like you Autoscale. There's lots of players in this space, but no one does a good job at keeping track of GPU costs because it's really complicated. They're like in Kubernetes pods, and you've got multiple users streaming in and out. It's like very hard to actually keep track of what you're spending your money on when it comes to deep learning. It's weird. But anyway, the total bill you can see because you have to pay that sucker, and it's big. So we were like, okay, we've got to be more careful about how we're going to scale all these deep learning models that we're getting into production for all our customers. And so we were thinking about how to do that. And there's lots of fancy things you can do, lots of really fancy things like distilling models and maybe using quantization, lots of ideas out there, all good. But I was thinking, like one thing we should seriously consider is not using the model at all. There's no cheaper way to use a model than to not use it. And so like, if only we could figure out how to determine whether any given piece of text that has to go through a deep learning model actually needs to go through it. So to pump your intuition here, if you have a typical like ML task and you have some classical ML model like XGBoost or Random Forest, really cheap, runs on CPU, you can spin it up with scikit-learn, super easy Python libraries. And if it can do like, let's say 60% accuracy on that test, well, that indicates that 60% of those examples didn't have to go through a deep learning model. If you could just know which 60% they were, you could feed them to this super cheap model, right? That's
are there also scenarios, John, where you can have logic where it says, okay, so this requires deep learning, but I can just use CPU for this?
How would you determine that?
I don't know.
That's the key, right? That's the rub. You got it. So if you could just, it's kind of like Maxwell's demon, in that classic thought experiment. If you can just like open and close the gate, you could make magic happen.
So the question here, so I get a query, so to speak, to the model, and the model now has to decide how to serve or answer this question, rather than defaulting to always use this gigantic, ginormous model.
Yeah.
Now you're going to have to bake in some kind of logic so that
It's a classification problem, actually.
Yeah. So then
This is an ML problem.
So then, in many ways, then you go, okay, so this query that the user sent, these entities are dead simple. I don't need some ginormous model for this, right? So
exactly. So, you know, if you have 1 million docs a day coming through your system, and you have to run them through 20 different machine learning models, your bill is going to be outrageous. So you want to like even drop that by 10% would be amazing. That's like 10% of your budget saved. And so
is there a cold start problem to this inference triage in the sense that in the beginning you just use the big model every time, right?
You got it. And what we do is we call this system that we came up with Baby Bear. So the idea is like that big model, that's your mama bear. Mama bear is like super powerful, but
baby bull and mama bull market instead of bear market.
Oh, no. We went with bears. You're right. That would have been. We could have gone with a more like cattle-based metaphor, but yeah, we went with bears.
So what is so rule of thumb on this cold start? How long or how many examples does it take before you have some?
So that was one of the first things we measured. So we took some typical classifiers that we have in production. So real, you know, this is real. We have these in production. We're spending like tons of money processing docs for customers. And so what we did was we put a little model. We tried XGBoost, Random Forest. XGBoost wins the day, by the way. It's just great. So that's that little guy we call Baby Bear. So we put it upstream. So the doc's coming in and Baby Bear tries to learn the task of Mama Bear. So if it's a classifier, like it has to try and do the same thing. And it treats Mama Bear as the oracle. So she's the source of gold label data. So in the warm-up period, it just observes Mama Bear and Baby Bear just trains, just like normal. And what we found is like, it'll take, you know, like.
I guess it depends on the task, right? So
it does depend on the task, but for most of the classifier tasks that we've run, Baby Bear can start to learn enough to save Mama Bear work within an hour, often within 20 minutes. So like you just turned it on and it's gonna get to work for you pretty quickly.
Oh, this is pretty cool. Yeah.
And our savings are about 50%, like sometimes as high as 90, which, you know, in those cases, it's like, wow, the deep learning model really isn't contributing that much. It's really just handling the very hard examples.
Have you tried to, so what is the trade-off on accuracy?
Well, so we bake that in. That's a parameter you control. You basically, the user, decide how much accuracy am I willing to spend.
Sacrifice.
So you could say 0, and then Baby Bear will do absolutely the best it can, but never, you know, like always hold back.
Okay.
And so we typically choose like between 1% and 5%.
Okay.
And we get up to 50% savings typically. So that cut our bill in half. It was great.
Right.
The paper and the code are online.
Ultimately, that's the end user's decision.
Yeah, exactly. Right. You get to decide. You can say, I don't want to sacrifice even a point of accuracy, and it'll do it.
But you pay Primer more money if you do that.
No, that's the sad thing is that we have to eat that cost. So we're motivated to make this efficient.
Right.
If it's hosted, but for our on-prem customers, this is like real money for them. So.
And and by
the way, if anyone wants to use this, it's all free online. We just open sourced it. The code and the paper are all out there.
What's the name of the project?
Baby Bear.
Baby Bear. So Primer GitHub repo.
Yeah.
Okay. Very cool. Custom summarization.
Yeah. Wow.
I guess, yeah. So before you start, I have a pet peeve, right?
Tell me.
Summarization is a tough. I mean, what's a good summary, right? So I guess you have to have like a human panel to evaluate what's a good summary. So there's no clear-cut way to determine what's a good summary, right? So what in your mind? So what is the right way to think about summarization, evaluating summarization?
Yeah. So just so that we're talking about the same thing. Traditionally, the task of summarization means, given this long document, write a really short document that I'm going to call a summary, which will explain the longer document. So you don't have to read it, or you know what it's about.
But what is a good summary?
Yeah. So traditionally, data scientists created these metrics that are still used today called rouge and bleu. They're named after French colors for some reason.
Right.
And the way that works is you take a set of documents and summaries written by humans. So these are called the reference summaries.
Right.
And you take some machine that is going to do summarization for you, and you have it write summaries for all those documents. So now you have the human written summary and you've got the machine written summary.
Which hopefully the human written summary is good.
Hopefully. And indeed, that's a big source of error, right? But hopefully it's good.
Yeah.
Usually the one that the benchmark that everyone uses is the CNN Daily Mail data set. So this is a whole bunch of articles written by journalists with summaries written by the journalists themselves.
I see.
Bullet point, like 3 to 5 lines. And the blue algorithm just measures how similar the words are. It's that dumb.
Right.
And that's crazy, right? Because you can imagine scrambling the machine written summaries into like word salad. As long as they overlap a lot with the n-grams of the human, it gets a great score. So that's like clearly a broken algorithm. But it is at least good for telling the difference between a terrible machine written summary and a decent one. But what it can't do is tell you the difference between a good one and a great one. Because if, imagine you and I had to summarize a document, we would write different summaries if we couldn't see each word. And so like, which one is the right one? Like compared to your reference, my machine might be good, but compared to mine, bad. That makes no sense.
And then there's these basic taxonomies around, like extractive summaries versus non, right? So
yeah, so there's a whole cottage industry around reformulating this as a question answer task. So like a good summary is one where you're with access to the summary, you'd be able to answer a bunch of questions about the document. The problem is like, great, well, how do you choose those questions?
Right.
Well, that's hard. Okay. Yeah. So we actually created a totally new way to measure the quality of a summary. And it uses a language model. So we just turned this on its head and said, rather than a human judge who would decide whether this is a good summary or not, we're going to have a language model just do what a language model does. So here's the deal. I give the language model the original document and I have it do the mass token task. So I hide 15% of the words and I say, hey, fill in the words, like guess what these are. And then I measure how good it does at that. And then I give the model access to the summary and do the same thing. And how much better it is at the task of quote unquote understanding the document by predicting the missing words with the help of the summary is some measurement of the quality of that summary. And what we did was we had a whole bunch of trained human experts actually rate the quality of summaries. And we found that this method, which we call Blanc, just in the tradition of French color names, is completely correlated with the humans. It's like, it actually looks like a typical human judge. And so now
is the summary, does it come up with novel sentences or basically extract sentences?
It depends on what kind of summarizer you use. We compared extractive as well as abstractive summary models. In production, we use both.
So without revealing clients or whatever situations, so what is so how reliable is the summary in the sense that are there examples where people really had to rely on the summary and it was mission critical to them?
Without naming the customer, we do have a customer who has a mission critical use of summarization. It's basically a briefing that goes to their leadership every day.
Right.
They have a part of that briefing that they wanted Primer to just like populate with summaries automatically to save them time. And we had to get it right. And so we really the whole research team thought about well, what can we do? And we have this wonderful engineer named Oleg. He's like the master of summarization. He's like a Ukrainian genius. Everyone has to have one Ukrainian genius. He's ours.
Yeah.
And he really went deep on this. And so this method, that I just described, Blanc, it's very good on all the dimensions of quality of a summary. You don't need humans to judge it. And so it can find bad summaries and rule them out. but for one dimension, which is factuality. It's actually not good at telling whether this summary has a fatal error, like a logical error in it. Like, dog bites man versus man bites dog. Those are very similar statements, but they mean completely opposite things. And so that's an example of like a really fatal error. And so he came up with a technique that we just published a paper on. Actually, I'm pretty sure it's in archive, but we submitted to EMNLP, so fingers crossed. I wonder if we're breaking any rule by. I don't.
I won't air this for another few weeks. So
I think we're fine.
Late September. Yeah.
Suffice to say, we came up with a really neat technique for estimating the factuality of a summary as well. And so,
by the way,
sometimes you do have to get it right, and it's amazing how hard it is to get it right.
So as you were talking there about summarization, it just occurred to me. So there's many now areas in ML where privacy is important, right? In particular, I imagine in NLP, there will be situations where you have to help a customer, but you can't really read the documents yourself.
That's welcome to my life.
So then, can you talk a little bit about that? So how do you actually how do you actually do that? I guess you have the metrics on the back end, so you can see if it's doing well, but then you can't even look at where I went wrong, right?
Yeah. Honestly, sometimes it's like dancing with someone who's not even in the room.
Yeah.
Yeah. So let me give you paint a picture for you of the worst case scenario, which is a government customer. So not only can you not see the data because it's classified,
right,
but the data lives in a classified system that isn't even connected to the internet. So and you need special clearance to even see that stuff.
Right.
In that case, we have what are called cleared engineers. So these are engineers who already have full security clearance and they can hands-on keyboard. So, but even then it's tricky, right? We've got our team over here, not classified, not cleared, working on this deep data science problem to help with a feature in some product, which is over the wall in government land.
But this is all has to happen over the phone or something because they can't really touch the data, right?
Yeah. So we have two tricks that we use. One is you do, this is the one I don't like, you do a game of telephone tag where it's they say as much as hey, there's a problem with the summarization and, or there's a problem with this entity recognition or whatever. I can't describe exactly what's going on, but there's a problem and it's of this variety. And here's what I think we should do.
How do I fix the problem if you don't describe it to me?
Well, often you can describe it well enough without compromising anything. But it's tough because you're dancing from a distance. The better way is you bring the data science in-house to the customer and you work on their data and you further fine-tune that model or that algorithm so it actually works on their data. That's way better.
I see. Interesting. No, it's a serious challenge, especially in NLP, because in many ways you need to understand. I guess this is true in any kind of data problem. You need to understand the data. All right. So next thing I wanted to talk to you about is another thing that fascinates me, which is synthetic text detection.
Oh yeah.
So before you go into what you guys did, a quick question, right? So let's say I'm on Grammarly.
Yep.
Right. So and then I have Grammarly help me fine-tune a sentence, rewrite it. Is that synthetic text in your definition of synthetic text? Is that synthetic?
Yeah.
So then you're gonna call me out. Hey, Ben, use Grammarly on the.
Well, I don't think we would be able to detect it if that's what you mean. I don't think we can detect Grammarly.
Okay.
That's undetectable.
But you consider that synthetic text. So then moving forward, there's going to be a lot of synthetic text.
Oh yes, it's a real problem, and also a real promise. It's both promise and peril.
Right. I actually use a similar tool from AI21 Labs called WordTune.
So, neat. I've heard about it, but never used it.
Yeah. So anyway, synthetic text detection. Tell us about it.
Okay. So this is work that came out of a so-called SBIR, a small business innovative research grant, I think it's called.
Right.
This is where the U.S. Department of Defense will fund a small company like ours to do some kind of work, and all in the public. It's like not a secret thing. And so one of the problems they wanted us to tackle was, imagine that there was like someone using a language model to generate stuff being said on the internet, like on Twitter or maybe YouTube comments. But it wasn't coming from a human, it was coming from a model controlled by a human. Could you detect it? That was the problem. So there's a lot of ways to tackle this, some much more complicated than others. And
what is your data set? What is the labeled data set in this case?
That's the problem. So that was the very first problem, is like, we have an immense data set of news. We actually are kind of hooked up to like, I don't know, 50,000 news sources, English language alone. So I have no shortage of like data going back years. And I wanted to know, can I even find synthetic text in here? Like, what I did was I ended up looking for like stories by journalists where there was like, I used a language model to write this article. So this is like gold data in the sense that like it's public, it's declared, this is synthetic.
And how much of that is there?
Almost none. Almost none.
Yeah.
And so then I just got on the internet and started searching. I was like, have journalists found examples of schemes where people have been using? There's almost none. And I was kind of like both relieved but also troubled. I was relieved that like, okay, the internet is not yet flooded with language model spam. That's good. But also I was like, well, where am I going to even get this data? So to even start working on this problem. So what I did was I made two teams, red team, blue team. Red team had a language model and tried to generate text. Blue team tried to detect it. And so we used news and Twitter and Reddit as the three data domains that we played with at various points. And so you can imagine, like, if you're the blue team, you've got this stream of stuff coming in. Some of it, you don't know which, is from a model, and some is actually originally from the internet, human written, presumably. And what we found was like, you need surprisingly little gold label data to make a classifier. And a human just can't tell the difference. So if I showed you like examples of tweets that were, or like news articles or Reddit posts that were written by a human and a machine, you wouldn't be able to tell them apart better than randomly, probably. But the classifier, once we gave it some examples, like, hey, these are known to be written by the machine, it was like in the 90s for F1. And it's really tricky to see what it's finding, but like basically models have tells.
So going back to my initial example, so you said you couldn't detect Grammarly, but that was because you didn't have Grammarly data, right?
Well, the key thing is you said it fine-tuned your sentence. You wrote it, but the model just made some changes.
Yeah.
So my presumption is that the Ben style factors will like overwhelm any of the Grammarly features.
I see.
And by the way, that's one of the unfortunate realities here, is that even if we were to make good detectors for synthetic text, all you have to do is have humans change them a little bit, and it degrades the performance of these detectors like dramatically. You just need a little bit of human in the loop, and an adversary can get around that classifier. So although we made this work in a sense, it was like, hey, we were starting from zero. Like, and the answer was, well, if you can find some examples of this nefarious, language model user, then you can probably quickly find the rest, or a lot of them. That's good. But also it reveals that actually it's not a sustainable solution. It would be whack-a-mole.
Yeah, and do you think a human in the loop in the following sense would also evade it? So let's imagine I have a troll army, and so that's been operating for a year. And so then now I use a language model and assign it to, like, Ben is a troll. Ben has all these examples of things he did in the past.
As a human.
As a human. Now you generate similar post as Ben. So do you think
that's absolutely doable? That's absolutely doable. In fact, there are legitimate startups doing this for marketing use cases.
Right.
So there's a really cool startup called Writer.
I see.
And that's what they do. They take the corpus of things that you or your organization has written, and gets a language model to make it easier to generate more.
No, but I'm more interested in the detection.
So let's say that the language model has been trained on 1 year of human written Ben content.
Yeah.
And now for the rest of this year, it's going to start taking over. So no more Ben, now it's the model.
Yeah.
So let's say that you suspect that Ben is a bot. Okay. One thing you can do is take a sample of Ben and train a classifier on it for old Ben versus new Ben. And you can just do the sampling technique.
Oh, I see.
And then what I would probably be able to find is like, oh, and there's also a John out here, you know, spouting a bunch of stuff, and it's like coming up positive for this thing in the same way. If
I'm just trying to come up with ways to make how to make trolls more productive.
You're on the wrong team.
and getting some advanced words. All right, so John, let's close with another favorite topic of mine, which is this notion of end-to-end solutions versus point solutions. Right? Because one of my pet peeves is there's so many startups in the ML ops world, which they're great, but they tend to be point solutions. And I think
what's one that comes to mind?
I'm not going to name names. They're all friends of ours.
Yeah.
But the problem is that companies want solutions to their business problems. They don't want to have to get into hire teams of engineers and platform people, right?
Yeah, and put another way, they want a solution. They don't want tools.
Yeah, exactly.
Like tools are neat, and maybe if the engineer at the company is a customer, you know, is the
and maybe 5-6 years ago you were forced to go into tools because there were no solutions.
Yeah,
but now but now increasingly for many areas you can get end-to-end solutions, right? So yeah. So what is the R&D part here?
Well, I think like if you want to make an end-to-end solution for a large number of problems or a problem that's shared by a large number of people, then it's actually mostly going to be software engineering.
Right.
So that's the kind of like open secret of ML, is that ML is actually useless without a very big supporting structure of software engineering.
Yeah. No, I mean, it's always been the case, right?
Yeah.
But then most of the mainstream media articles about ML is about models.
I know, because it's funner to talk about.
Yeah. And actually, one of the things that I find amusing is suddenly there's a renaissance around this so-called data-centric AI, whereas most of us on the practitioner side have always known that data is more important than model.
I think you're giving us too much credit. Because I think the craze for language models, you know, came from our neighborhood. You know, it's like, oh, we can make these bigger and bigger and have all of these emergent skills.
No. But I mean, if you talk to anyone who's worked building models in a company, most of the time they're really just.
They know.
You know, when they get to the modeling side, they're already just having fun, right?
Yeah. It's all data. It's all data. All the pain and all the gain is on the data side. So your question was, where is R&D in all this? And
on the end-to-end stuff.
Yeah. And I think like there's a couple places where R&D really helps. One is, you know, that those ML black boxes in the middle of all this, of course. You know, like if it can't do the job, then it doesn't matter how beautiful your end-to-end platform is. It doesn't.
It has to be a level of accuracy that the client will deploy it, right?
And indeed, like it has to have certain skills, Sometimes like it doesn't even have those skills. Right. And so, you know, it's not a question of accuracy. It's a question of, is this even in the art of the possible? So a lot of R&D there, of course. Right. There's another way that R&D really matters. And this is like a passion of mine is, okay, great. It does the thing. You've got an ML model that does the thing. It's fine. But your end-to-end solution is incredibly expensive and slow. So that's another place that R&D can really help.
Yeah. And duct tape together, right?
Well, there's that.
So fragile.
There's that, but I feel like software engineers without research are the ones who save the day on that front. But sometimes it's just a question of like, well, how do we like make this thing fast and cheap? And there's a lot of research going into that. So, and we're part of that, and it's fun. It's great to do research, and then you see your monthly bill go down, and you know that you did that. That's like really satisfying.
So let's close, John. Let me ask you. So if you have someone who's fresh off ML PhD, NLP PhD, so how do you turn them into real world production NLP or ML engineers?
Well, I would say.
So is there a primer? Is there a primer boot camp that you guys have?
Well, I would say if you did a PhD, you're already pretty far along, and you may have gone farther than you need to.
No, but that's PhD writing papers. Now you're inside a company, building products. So, do you have a program to help people with that transition?
It's a pretty easy transition to make, I find. You just describe like what our shared goals are, and people want to have impact. That's what's really lovely about working with good people is like they just jump on the tasks that matter most and they find their way. So like we're very wary now of rabbit holing on really scientifically interesting but really deep, like no clear impact. Like if it does have impact, it'll be way down the road. We're like very cautious about that work. We do some of it because you got to make some risky bets.
Right.
But for the most part, what you end up doing is you take a look at the problems that exist. And we have a process for this. I call it the hopes and fears tour. Every quarter, we go team to team, the different product teams, and we say, okay, what are your hopes and fears that we could help with? A hope is something like, I wish this existed or this worked better. And a fear is like, I think like this is just not going to actually work well enough for the customer at all, or this is going to be too expensive or whatever. So we kind of gather those and we bring them back and we kind of think about it and we put them all together in a big bag and then we prioritize them. And then we create what we call the portfolio. What's the mix of research bets you're going to make this quarter? Some, safe, like low effort, medium payoff. But, you got to have some that are like really risky, but man, if that works, that's going to be great. And so I find that people like from academia, even, they slide right into this kind of rhythm. It's a really nice way to do research because it's tied very closely to impact. That's why we call our team the applied research team. We just like make it super clear. Our goal is application.
And at a place like Primer, you won't be lacking for data.
Well, yeah. I mean, it's a blessing and a curse. And also with NLP, you sometimes you have a data desert. Yeah. To give you an example, we're working on a model right now. An amazing engineer named Ben. He is working on a model.
Great name.
Yeah. This is Ben Arar, different Ben, and he's working on a model that will detect the intent to do harm. So someone like basically threatening someone on social media or in chat, whatever, we want to make a classifier that will find that. Where are you going to get that data? Like the various platforms out there are getting increasingly good at banning people who are threatening. And so a little bit of a needle in a haystack problem. And so sometimes you have like not enough data, even if you have like all the world's news and all the world's social media at your fingertips. You can't find those needles in the haystack.
By the way, John, just to close, I forgot to ask you this early on. So is Primer mostly English and Western languages?
Increasingly multilingual. Our home base is English, just like everyone else. That's where we cut our teeth and made all our original work. But our customers, especially in government, they care about the whole distribution of languages, including low resource.
Okay.
I'm very excited about Bloom. Have you heard about Bloom?
Oh, yeah.
The Hugging Face Big Science project is super exciting.
Yeah. And with that, thank you, John.
Thank you.